we are moving into kind of geometry, but it's not like the kind we've been doing. It is transformations. Today we're going to talk about translations, 19.1. I can translate a figure and use an algebraic expression to represent that translation. So the first thing we're going to talk about is a transformation. This is kind of the broad term for everything we're going to do in 19 and 20. A change in the position or orientation of a figure. Okay, so it's like taking a starting point and then changing where it is or how it like gets moved. So a pre-image is what we call the original figure in a transformation. Okay, it's the original. The image is the figure that results from a transformation. So this is like our starting point. Right, and maybe this is our ending point. That's not good. And then, so the main one we're going to do on this note taker is translation. It's a movement, what we call a slide of a figure along a straight line. So it's just left, right, up, down, and then you can do two of them to make it kind of go diagonally. Okay? So we can do left, right, up, down, and diagonal. I probably spelled that wrong. All right, so figure shows triangle X, Y, Z. This is our pre-image. Graph the image of the triangle after a translation of 4 units to the right and 1 unit up. Okay, so this is our translation right here. 4 right, 1 up. This is our pre-image. Okay, the starting point. So you can see that, I don't know if these lines showed up, but all we really are going to do is count, literally count 4 units to the right. 1, 2, 3, 4, and then 1 up. That's it. So there's Z prime. That's what we call it. We put a little tick mark on it. It's called Z prime. Okay? Now we have to move every single point the same way. So we're going to take Y from the pre-image, 1, 2, 3, 4, and we're going to move 1 up. And this is Y prime. And that's our image. And again, we have to do this one. 1, 2, 3, 4, 1 up, X prime. And then what we do is we take our points and reconnect them. And that's our image right there. Okay? So there's 2 ways they can give you a translation. One is just telling you exactly how to do this. Okay? The other way is our algebraic. Okay? And the way we're going to do that is we're going to actually look at the pre-image and then the image to see what happens, okay? So I'm going to write down X. It's at -4, 1. And then I'm going to look at, let's do Z. It's at -2, 1, 2, 3. Oh, -3. And then Y is at 0, -1. So then we're going to do our prime. So X prime is this one right here. It's now at 0, 2. And, oh, Z prime, Z prime is at 2, 2. Oh, -2. Let's keep saying that negative. And then Y prime is now at 0, 1, 2, 3, 4. Nope, 4, 0. This way, 4, 0. So what we're going to do is we're going to look at what did happen to the x's. Remember, this first one's the x, and the second one's the y. All right, and this is kind of be like our x prime, y prime. What we want to do is what did happen to our x's to get our y's? I mean, to our x primes. And then what happened to our y's to get our y primes? So if we look, -4 to 0, what did I do? I added 4. -2 to 2, add 4. 0 to 4, add 4. And so we would say that x got added 4. All right, to get from here to here, we're going to add 4 to my x's. So then we're going to do the same thing for our y's. So we have 1 to 2, plus 1. -3, -2, that's plus 1. -1, 0, that's plus 1. So we're going to go y plus 1. So anytime you move to the right, you're going to add. And anytime you move up, you're going to add. But that makes sense too on a number line. If I move to the right, I'm going to make the numbers bigger. I'm going to add. And if I move up on a number line, like a thermometer, the numbers get bigger, so I'm going to add. So that then brings us to the next example. We're going to move 4 units to the left and 2 units down. Okay? So if this is just the actual translation. So let's do it, and then we will decide what our algebraic representation would be. So we're going to go 4 left, so 1, 2, 3, 4, and then I'm going to go 2 down, 1, 2. And this is where Q prime is. Now, if you don't want to count the little humps, you can actually just count. So I'm going to do this a little differently for P. So I'm just going to go 1, 2, 3, 4, 1, 2. Kind of makes the stuff go away. All right, they're all this way my graph's a little cleaner. So then R, 1, 2, 3, 4, 1, 2. There's R prime. So notice that time I didn't even touch it, so there's not even any dots. And then S, 1, 2, 3, 4, 1, 2. And so S prime. And then we reconnect them to get our image. So you'll notice I have the exact same image. I have the same exact figure. I just slid it diagonally on a straight line. Alrighty. So P is at 1, 3. Q is at 1, 2, 3, 4, 1, 2, 3, 4. R is at 1, 2, 3, 4, 1. And S was at 1, -1. So then we're going to see what happened to P prime, Q prime, R prime, S prime, so that we can write this algebraic expression. So P prime is now at -3, 1. Q prime is at 0, 2. R prime is now at 0, -1. And S prime is at -3, -3, right? No, 4. 1, 2, 3, 4. All right? Did I count right? 1, 2, 4, 1, 2, 1, 2. Oh no, 3. I was right. Sorry. So 3, -3, -3. I was right the first time. Okay. So what I want you to do is maybe pause and see if you can write the algebraic expression to change xy. What did we do to xy to then get my image? Okay, so if we look at it, we should have gotten that x was subtracted by 4. Right, we subtracted 4 from all of these. See, 4 take away 4 is 0, 4 take away 4, 1 take away 4. That's because when we move left, we subtract. And then y was then subtracted by 2. That's because we move down, we subtract. And look, there's my 2 and my 4. So it's the same exact numbers, and I just have to decide if they're being added or subtracted. And notice that here too, it was 4 and 1. All right, the first one was 4 and 1. I just need to decide if I'm adding or subtracting. All right, so maybe pause here, do this one completely on your own. Not only find the image, but I want you to write the algebraic expression. What happens to x and y to get, actually a little bit of room, to get my prime, or my image, or my prime, yeah. So pause here, try this on your own, and then check it with mine. All right, so it says 5 left, 2 down. I will tell you just from that information alone, I could write the algebraic expression. I'm going to go -5, -2. Left is always subtraction, down is always subtraction. So I just take those numbers and do that. Okay, so A, 1, 2, 3, 4, 5, 1, 2. I know it's hard for you guys to see your graph, so just do the best. That's A prime. 1, 2, 3, 4, 5, 1, 2. Okay. See how they line up here as they line up here. 1, 2, 3, 4, 5, 1, 2. And then 1, 2, 3, 4, 5, 1, 2. And then again, it's a good check that C and D line up. And there's my image. So pre-image, image, algebraic expression. Okay, so hopefully that went well. All right, so things to remember. Left, we subtract from x. Right, we add, I should say 2x, huh? 2x. Up, we add to y. Down, we subtract from y. And then don't forget to do your independent or your algebraic expression for the independent practice as well. So a figure shows trapezoid W X Y Z. Graph the image of the trapezoid after a translation of 4 up, 2 left, and then make sure you write your algebraic expression. So x y goes to what? And then write your algebraic expression. And then also make sure you graph the image as well, okay? All right, until next time.